Hello students, this is Chapter 1, Lesson 2 of Algebra 1. Today in our journals we are starting on page 7. In the directions of Exploration 1 we are told that the sum, meaning adding all the angles together, so the sum of the angle measures in a polygon with n sides can be found by using this formula. So what they want us to do is write and solve an equation to find each value of x, justify your steps, and then find the angle measures of each polygon. Okay, so I'm going to take a look at letter A, and I notice that I have 3 angles. So my first step is to figure out what the angles all add up to. Now from a previous class, I know that the angles of a triangle add to 180 degrees. So I know that all of these angles add up to 180, so now what I'm going to do is add my like terms. I see a 30 and a 30, so that's going to be 60. And now we need to add together our other like terms. We have an x and a 9x, and so that equals 10x. Now we just need to solve for the variable. This is a two-step equation. I see that I have my variable here, and it's being multiplied by 10, and it's also adding 60. So in order to undo those, I need to undo my adding or subtracting first. So I'm going to take off the 60 first. And that leaves me with 120 equals 10x. Now I still need to solve for x, and so this time x is being multiplied by 10, so I'm going to divide by 10 on both sides, and I get 12 is equal to x. So that is my answer for x. Now all that remains is for me to take my value of x and plug it back into the problem in order to find out what the angles are. So we already know that this is 30 degrees because that's what we're told. This one up here is 30 plus x. We know that x is 12, so that means that this angle is going to be 42 degrees. And the third angle is 9 multiplied by 12, so that gives us 108 degrees. So these are the 3 angles that we have in our triangle. Number 2 is done very similarly. I know that the 3 angles in the triangle add up to 180. And so now let's add our like terms. I have 50, 10, and 20. So that's 80. And then I'm going to add my 2 x's. So I have x there and x there, so that's 2 x's. So I'm going to go plus 2x. And now I need to solve for x. And when I solve, I get x is equal to 50. Now when I plug that back in to my 3 angles, I see that this is already 50 degrees. I don't need to do anything with that. This one up at the top here is x, which we got is 50, plus 10. So that's going to be 60 degrees. And then my third angle is x, which we got is 50, plus 20. And so that's going to be 70 degrees. Okay, let's take a look at letter C. On letter C, we need to count our angles. 1, 2, 3, 4. So this time I'm going to go ahead and use this formula up here. The formula tells me I take 180 and then multiply that by how many angles there are minus 2. So in this case, since I have 4 angles, we're going to do 180 multiplied by 4 minus 2, which is 180 multiplied by 2. And that gives us 360. So 360 is how much the angles all add up to in a quadrilateral. Okay, let's go ahead and add our numbers. We have 30, 20, and 50, so that's going to be 100. And we'll add together our x's, so we have 2x, 2x, and x. So that's going to be 2 plus 2 and plus 1, so that's going to be 5. So this will be 5x. Okay, I got x is equal to 52. So now we're going to plug in our 52. So at the top here, this is just plain old 50. There's nothing we need to do to that. The one at the bottom is just x, so that's 52 degrees. And then we have 2 times 52 plus 30, so that gives us 134. Lastly, we have 2 times 52 plus 20, so that's going to be 124. Letter D is also a quadrilateral, so that means that we're going to have 360 as our total again. And so now let's add up our numbers. So we have 42 and 35. Oh, look at that, there's a negative 17. So that means we need to subtract 17 off. So it'll be 35 plus 42, and then minus 17. So that gives us 60. Now we need to add together our x's. So we have x, 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 and x. There aren't any numbers in front of them, so there's just 4 of them. So we're going to say 4x, and now we need to solve for x. And I get 75 is equal to x, and now it's time to plug it back in. And that's what I get when I plug it back in. Okay, we're going to go ahead and not look at E and F just for the sake of time. So go ahead and skip in your journals to page 10. All right, I'm going to do the even numbered problems, and I'll let you try the odd numbered problems on your own. So on number 2, I'm going to circle the variable and draw my line. So I need to undo what's happening to the z. Right now, that means I need to add 13 first, and that leaves me with 5z equals positive 10. Now divide by 2. I meant to say 5 here. 5 is what you divide by. And that leaves me with z is equal to 2. Okay, so now if I wanted to check my solution, 5 multiplied by 2 minus 13 should equal negative 3. So that's 10 minus 13 equals negative 3, which is correct. On number 4, here's my equal sign, and there's my variable. This time what I want to do first is combine like terms. So on the left I have 15, 2 plus 4 is 6. So now we have 6 minus d. So now I still need to solve for d. I'm going to subtract 6 on both sides, and that leaves me with 9 is equal to negative d. Okay, so negative variable is the same as negative 1 multiplied by that variable. So if we think about this as a negative invisible 1 here, what we need to do is undo that multiplication of the invisible negative 1. So I'm going to divide out negative 1, and that turns the variable into a positive variable. And now on the left we have 9 divided by negative 1, which is negative 9. And so there we have as our answer. So let's check that and see if we did that right. 15 equals 2 plus 4 minus, and then d is negative 9. So notice I have a double negative here. So that would be 15 equals 2 plus 4 is 6. Double negative means plus 9. Ah, there it worked. Very good. All right, on number 6, I have a q that I need to solve for. And so what I notice is that this entire amount here is being divided by 3. And so the easiest way to do this is to get rid of that 3 first. So since everything is being divided by 3, what I can do is multiply the whole entire amount by 3. And when you do that, 3 divided by 3 is 1, so that goes away. And what we're left with on the left-hand side is q plus a negative 5. And then I have, since I multiplied by 3 on the left side, I have to multiply by 3 on the right. 8 times 3 is 24. And now since it's plus a negative 5, that's the same as q minus 5. So I'm going to add 5 here to make that go to 0. So that's now 0. So now q is equal to 24 plus 5, which is 29. And let's plug that in. So 29 plus a negative 5 divided by 3 should equal 8. And it does indeed work. Okay, I would like for you to try 1, 3, and 5 on your own. Okay, here's what I got. Number 1, x equals 5. Number 3, z equals 8. And number 5, f equals negative 16. If you didn't get it right, just pause the video and see if you can find your mistakes. All right, number 8, I'm going to draw my line, and I'm going to circle. This time I have 2 variables. So whenever you have 2 variables on the same side of the equation like this, the first step is to combine like terms. So this is 5z's minus 2z's. 5 minus 2 is 3. So that leaves me with 3z minus 4 is equal to negative 7. So now I need to undo what's done there. So I add 4 first, and I get 3z is equal to negative 3. Now I'm going to divide by 3, and I get z is equal to negative 1. Okay, let's plug that in and see if that worked. 5 times negative 1 minus 2 times negative 1 minus 4, I'm almost out of room here, equals negative 7. So 5 times negative 1 is negative 5. Negative 2 times negative 1 is plus 2. Minus 4 should equal negative 7. So this is going to be negative 3 minus 4 equals negative 7, and that works. Okay, good. Let's take a look at number 10. So I'm going to draw my line. Again, I have two z's here, so I'm going to combine 9 and negative 4, and that gives me with 5z minus 5 equals negative 5. So now I need to solve for z. So I'm going to add 5 to both sides, and that leaves me with 5z is equal to 0. Divide by 5. Any 0 divided by any number will always get you 0, so this is going to give me 0. By the way, if it was the other way around, if it was 5 divided by 0, that would be no solution. That's not what we have in this case, but I just wanted to point that out to you. 0 on the top is okay, 0 on the bottom is not. So z equals 0. Okay, so let's plug that in and see if that works. 9 times 0 minus 5 minus 4 times 0 should equal negative 5. So 9 times 0 is 0, minus 5 minus 4 times 0 is 0 equals negative 5, and that does work. Okay, you try number 7 and 9 on your own, and then turn the video back on and check your work. Okay, number 7 is 7 over 2, and number 9 is 5 over 2. You'll notice that I always like to leave things in improper fractions. And the reason why I do that is because when I plug it back in to check my answer, it's a whole lot easier to solve. I don't need a calculator if I leave it in improper fractions. Okay, number 12. So this time my variable is inside the parentheses. So in order to solve this problem, my first step is to distribute the negative 4 into the parentheses. So negative 4 times z is negative 4z. Negative 4 multiplied by negative 12 is going to be positive 48. And the rest of this is just like what we did on the other side. We're going to subtract 48 on both sides and then divide by negative 4. And I got z equals 3/2. I went ahead and plugged it in to make sure that that worked. Okay, so let's take a look at number 14. Again, our variable is inside the parentheses, and so my first step is to distribute. So 7 plus 3 times 2g is 6g, and 3 times negative 6 is negative 18 equals negative 29. So now I have two that don't have variables, so we're going to combine those together. So I'm going to keep my 6g here, and 7 and negative 18 is negative 11. And we'll go ahead and solve from there. Okay, I ended up getting g equals negative 3, and I plugged it in to make sure it worked. Okay, you do numbers 11 and 13 on your own, and then turn the video back on and see if you got it right. Okay, on number 11, I got z equals 0, and on number 13, I got r equals 4. Okay, number 15 I think is written poorly. I'm going to be honest with you. When I read this, it says you can represent an odd integer with the expression 2n minus 1, where n is any integer. Write and solve to find 3 consecutive odd integers with the sum of 63. I don't like that first sentence. I think it confuses me, and for me personally, I'm not going to bother looking at it. I'm just going to take a look, write and solve an equation. I want to find 3 consecutive odd integers that have a sum of 63. To me, that's the most important part. So if we think of the first number, we don't know what it is. I'm going to call it x. The second number, it's an odd integer. So that means that, think about odd integers. 1, 3, 5, 7, 9, 11, etc. So anytime you have odd integers, you're adding 2 each time, right? Anytime you have an odd, you're adding 2. So if they're consecutive odd integers, you're always adding 2. So our second odd integer will be x plus 2. And then our third odd integer is going to be, this time we start with x, but this time we're adding 2 more. So it'll be x plus 4. Okay, so now we're told that they have a sum of 63. And so what I'm going to do is add all of these together here. We have 3x plus 6 is equal to 63. So if I solve for x, I'm going to get 3x equals, subtract 6 on both sides, we get 57. And so x is equal to 19. So that means that my first odd integer is 19. So this is going to be 19. My second odd integer is 19 plus 2, which is 21. And my third odd integer is 19 plus 4, which is 23. So my consecutive odd integers are 19 and 23. So these are my answers, and let's double check, do they all add up to 63? So 19 and 21 and 23. So that'll be 13 here, so 4, 5, 6, yep, it does. If you could figure out, every time I've done this, used this book, I don't know what they're talking about here. So if you can figure that out, if you figure that out, let me know. Because to me, that first sentence just makes the whole thing way more confusing than it needs to be. All right, let's take a look at number 16. It says one angle of a triangle. So I'm going to stop right there. We have a triangle. So I like to draw pictures. So I'm going to draw a picture of a triangle here. It doesn't really matter what my triangle looks like. Okay, so one angle of a triangle has a measure of 66. Doesn't really matter which one we choose. This is obviously not going to be drawn to scale. So I'm just going to put 66 there. So one measure of a triangle equals 66. The measures of the third angle is 57 more than half of the second angle. Okay, so let's just make, we don't know what one of them is, but we do know that the third angle is 57 more. So we're going to add 57, then half the measure of the second angle. So 1/2 of x. So 1/2 plus 57 is that second angle, and the third angle would be plain old x. We're told that the sum of the angle measures in a triangle add up to 180. We've known that from before. So what's the measure of the second angle? This actually goes back to the questions that we did on the previous page, right? So let's go ahead and add our numbers together. We have 57 and 66, so that's 123. And then we have an x plus a half x, so it's 1.5 x. I'm going to change it to 3/2 x. And so that will add up to 180. Okay, so now we just need to solve for x. I'm going to subtract 123 from both sides. And now let's multiply by the reciprocal, so 2/3. Okay, since 57 divides by 3 and gives us 19, that makes that a little bit easier. So now we have 19 times 2, which is 38. So that means that we have 38 is one of these angles, and then the other one is 1/2 of 38 plus 57, and so that's going to give us 76. So 76 and 38 are the two unknowns. All right, last question. Your cousin is 8 years older than your brother. 3 years ago, your cousin was twice as old as your brother. How old is your cousin now, and how old is your brother now? Okay, so there's kind of two parts to this. I'm gonna think about this in terms of now and 3 years ago. So we have two characters. We have a cousin and we have a brother. Okay, let's read it again. So it says, your cousin is 8 years older than your brother. So this is what's happening right now. So that means if your brother is X, then your cousin is 8 years older. So we're going to add 8 to X, X plus 8. Okay, but 3 years ago, your cousin was twice as old as your brother. So it's 3 years ago. So whatever we do, we need to subtract 3 off of X, because X is what he is right now. X is what your brother is right now. So 3 years ago, your brother was X minus 3, right? And your cousin was twice as old. So now at 3 years ago, your cousin was twice as old as your brother was at that time. So 2 times X minus 3. Okay, so now let's see if we can figure out what's going on. Okay, so this is kind of tricky because it says your cousin is 8 years older than your brother. So that's always going to happen. That's a constant. The cousin is always going to be 8 years older. So if we think about this also 3 years ago, the cousin is still 8 years older than that brother. So if the brother is x minus 3, then the cousin is going to be x minus 3 plus 8, because 3 years ago the cousin is also going to be 8 years older. That's always going to happen. So that means that these two pieces here are going to equal each other, okay? So what we can do then is we can say that 2 times x minus 3 is going to equal x minus 3 plus 8. And so if we solve for that, we get 2x minus 6 equals x plus 5. And this time we have variables on both sides. So I'm going to move one of my variable over. And so that cancels it out of that side. So we get x here. At the same time, I'm going to add 6. And so I can combine those two steps into one. And so when I do that, these cancel, and 5 plus 6 is 11. So that means that the brother is 11 years old, and the cousin is going to be 8 years older, or 19. Okay, thanks for watching.